Okay, guys. Gonna do a real quick video here on matrices to get you guys going again on that, and hopefully refresh your memory on some of it. I know some of you were gone, so it'll be a good way to catch you guys back. Okay. A matrix. It's really just it's a rectangular array of numbers for the most part. Okay. Now I'm going to use the word elements because that's officially what they're called. So it's a rectangular array of elements. It's a way to organize information. It's similar to Excel in a sense, okay, where you're putting values into a specific cell or a specific location, and usually they have some sort of meaning. You know, the rows mean something, the columns mean something, things like that. Okay. So you might have a matrix that looks something, just kind of random there, okay, where it's a rectangular array of elements. This one had 6 particular elements in it. I just used variables here for the time being, okay, just kind of random order, nothing special at all about it, okay. This matrix here would be a 2 by 3 matrix because it has 2 rows and it has 3 columns. I can spell. Okay, so it is a 2 by 3 matrix. We always do rows by columns when we describe a matrix on its size. So this element is in the first row, first column. This element is in the first row, second column. First row, third column. Second row, first column. Second row, second column. Second row, third column, and so on. Okay? Everybody okay with that? Questions so far? Okay. Some matrix notation that you may see if you take some sort of advanced math class where you start using a lot of matrices, such as a linear algebra or something. If you ever see something like this, a variable, lowercase a, and then 2 values here, what they're asking you is to identify the element that is in the first row and the third column. Okay, so if you ever see this notation in a class, so it says find a sub 1 comma 3, they're asking you to find the element in this matrix that's in the first row, third column. What element is in the first row, third column? Negative 3. Okay, so again, that's just matrix notation that we use once in a while. Okay. Matrix operations, pretty simple. If you want to add or subtract matrices, you must have what? Who remembers from Friday? Exact same dimensions. You must have the same dimensions. And all you do is you add or subtract the corresponding elements. Okay, so you take the whatever number's in the first row, first column, and add it to the other element that's in the first row, first column, or subtract whatever it is. So you just add or subtract the elements in the same position. You might need to see an example with that, or feel like you understand what we're doing there. Okay. There's scalar multiplication. essentially where you have a matrix of values and you multiply it by, a scalar. When you do scalar multiplication, it's a lot like the distributive property. You're essentially multiplying this 5 to all of the elements inside that matrix. So 10, negative 15, 20, and 30. That's an example of scalar multiplication. 5 is your scalar. It's the number you're multiplying every element in the matrix by. Pretty simple. Okay. Then we had matrix multiplication itself, just regular old multiplication. And in order to multiply matrices together, what did we determine we had to have?
The columns in the first one have to be the same as the rows of the second one?
Awesome. Yep, the number of columns in the first matrix has to match the number of rows in the second one. Okay? So, if you have an M by N matrix, and you multiply that by an N by P matrix, that is possible. Because the number of columns in the first matrix matches the number of rows in the second. These two values right here, they have to match each other. If they don't, you can't do it. You say impossible, undefined. Okay? So these have to be equal right there. These two values there have to be equal. The number of columns in the first one has to match the number of rows in the second one. Okay? And then, yes?
Could that be reversed? Like, could it go rows in the first one, columns in the second?
Nope.
Okay.
It has to be exactly this, and that's the only way you can multiply them together. And once you see us do an example, you'll understand why, based on the procedure that we need to take in order to multiply matrices together. Okay? Good question. Has to be these two here. Then these, whatever values these are, okay? Whatever numbers these are, these become the dimensions of your answer, or the dimensions of the product. Okay? So these are the dimensions of the product. Okay? So matrix multiplication. We did one of these on Friday. Okay? Let's go. Let's take a 2 by 2 and we'll multiply it, say, 2 by 3. Okay? So first of all, let's check to see if we can actually do this matrix multiplication. What are the dimensions of the first one?
2 by 2.
2 by 2. What are the dimensions of the second one?
2 by 3.
2 by 3. So what you do is you look at these two values right here. Are they the same? Yes, they are, so that means we can do it. Then, now that we know we can multiply these two matrices together, I look at my two outside values to say, okay, that means my answer is going to be a 2 by 3. Alright? So my answer will have 2 rows and 3 columns in it. Okay? I'll have 2 rows and then I'll have 3 columns. So I'll end up getting an element here, an element here, an element here, 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 and here. Okay? The way you do this, remember, is we multiply across rows and down columns. So in this first matrix, I'm going to go across this row and I'm going to multiply it with each column in this one. So I'm going to go across this row and down this column. So 2 times negative 1 plus 4 times 4. I'm going across the row and down the column. So that'd be negative 2 plus 16. I take 2 times negative 1 plus 4 times 4. So negative 2 plus 16. I'll even just write that workout right here. And obviously you guys can probably write the answer in, but you're going to have to show me how you got to your answer, okay? So show me some sort of work. You can write out all the multiplication if you want. If you want to write negative 2 times 1 plus 4 times 4, that's fine, and we're just products of those. Okay? What will I do to get this answer right here? First row, second column. So tell me the math. Very good. 2 times 5 plus 4 times 6. So 10 plus 24. Okay? Somebody different. Let's get this one. Laney?
2 times 0 and then 4 times 4.
So 2 times 0 plus 4 times 4. So 0 plus 16. Okay? Somebody different down here. What am I going to have to use? So right like this.
Yeah.
Okay? So negative 3 plus negative 4. 15 plus negative 6. 0 plus negative 4. Final answer. 14, 34, 16, negative 7, 9, negative 4.
So is that's it?
Yep.
Okay. Seems easy enough.
Yep. That's matrix multiplication. Once you get to do a couple of them, I think it's pretty simple.
Is there division in here anywhere?
Nope.
Oh, thank you.
There's multiplying by the inverse.
Okay. Wait, what did you just say to me?
Multiplying by the inverse. I compare it to if you divide both sides of, think of an equation. You could divide both sides by a fraction, or multiply both sides by the reciprocal. The reciprocal is known as the multiplicative inverse. That's exactly what we do with matrices. There is no division. We'll just be multiplying by an inverse of a matrix.
But there's division. Okay.
To some degree, technically,
There's
yes,
division.
there's division.
So there's more than just this.
Well, argue, I'd say there isn't division.
I don't want to argue. I just want to know how sad you
In theory, there's division.
Yeah, there's more than just this.
It's in
Really,
the background.
subtraction and division don't exist.
But yet they do to some degree.
No, you just add opposites.
God,
Multiply by inverses.
That's what
Ah.
the section would be. You don't have to.
So that's kind of a real quick synopsis of matrices, adding, subtracting, scalar multiplication, and regular multiplication. Okay? Any questions on that so far? Okay, we'll stop the video for right now.